Welcome to the deep dive. Today, we're really going to dig into something specific. Key ideas for the Nutanix NCA 6.10 exam.
That's right.
We've got some practice questions, some explanations based on the materials. The mission is basically to get you a solid grasp of these core Nutanix concepts, quickly and efficiently.
Exactly. Think of it as a focused briefing. We're not just spitting out answers. We want to unpack the why behind them so you really understand the principles.
Right. And just for context, the NCA 6.10 itself, it's 50 multiple choice questions. You get 90 minutes, available in English and Japanese.
Okay.
Testing score is 3,000, and it's $99 per attempt. So worth getting it right.
Good to know the basics. All right, let's jump in.
Let's do it. Okay, first area. Cluster health. Question 1. Which Nutanix tool is used to verify cluster health and configuration? Options are A, NCC, B, Foundation, C, Calm, and D, Prism.
Okay, this one should be pretty familiar to folks working with Nutanix. The answer is A, NCC.
NCC, Nutanix Cluster Check.
Right.
That's the go-to for making sure the cluster is, well, healthy.
Exactly.
Can you elaborate a bit on why NCC is so crucial? What's its main job?
Well, NCC is essentially your cluster's regular checkup tool. It runs a whole battery of tests, checks configurations, looks for potential issues, hardware problems, software inconsistencies, things like that. It reports back on anything it finds.
So it's proactive,
Yeah,
trying to catch things before they cause real trouble.
precisely. It's about preventative maintenance, basically. Instead of reacting to fires, you're looking for the smoke. Keeps things running smoothly, minimizes downtime. That's the key value, I think.
Makes sense, like a constant health scan. Okay, so if the cluster is healthy, what runs on it? Applications, right?
Absolutely. That's the whole point of the infrastructure, isn't it?
Which brings us to question 2. What is the main function of Nutanix Calm? Options. A, VM provisioning. B, application lifecycle management. C, backup management. D, node configuration.
Okay, calm. The answer here is B, application lifecycle management.
Application lifecycle management. Calm. Sounds like it brings order to chaos. What does it actually do for an application?
It really does try to bring order. Think of Calm as the orchestrator for your apps. It uses blueprints to define how an application should be deployed,
Okay.
how it should be scaled, updated, managed, even, eventually retired across different environments too, potentially clouds, on-prem.
So it's not just the initial setup, it's the whole lifespan.
The entire journey, exactly,
Absolutely.
from start to finish, it automates all those steps, which is really powerful.
What's the big benefit there? Why automate all that?
Well, automation saves a ton of manual effort, obviously, but it also reduces errors. You get consistency every time you deploy or update.
Right. Less chance of someone missing a step.
Exactly. And that means faster deployments, more agility. You can respond to business needs quicker instead of getting bogged down in, repetitive setup tasks. Frees up IT teams for more strategic stuff.
Got it. Streamlining operations. Okay, let's shift down a level to the hardware itself, the nodes.
The building blocks, yeah.
Question 3. What is required to deploy a new Nutanix node in the cluster? Options. A, Foundation tool. B, Prism Central. C, LCM. D, NCC.
For deploying a new node, the answer is A, the Foundation tool.
Foundation. The name kind of gives it away, doesn't it? So this is the starting point for adding hardware.
It absolutely is. Foundation is what you use to basically prep a new node and introduce it to the cluster.
Prep it. How? What does it handle?
It does the initial hardware configuration, installs the necessary Nutanix software, like the hypervisor and the controller VM, and then it integrates that new node into the existing cluster. So everyone knows it's there and can start using its resources.
So it makes sure every new node starts off on the right foot, configured correctly.
Exactly. Consistency again. Without something like Foundation, adding nodes could be, well, a real headache. Much more manual, more prone to errors.
Why is that standardization so important when you're adding nodes?
In any distributed system, consistency is key for stability, right? Foundation ensures every node is set up the same way, using the right software versions. This avoids weird compatibility problems down the line.
Okay.
And it makes scaling predictable. You add a node, it just works. Plus, it simplifies management later on.
Right, a solid base for growth. Now let's talk about keeping the data safe on those nodes. Redundancy.
Super important. Data availability.
Question 4. What is the minimum number of nodes required for RF3 in a Nutanix cluster? Your options. A3, B4, C5, D6.
Okay, replication factor 3, or RF3. For that level, the minimum is D, 6 nodes.
6 nodes, wow. That's quite a jump from the usual minimum for a cluster. Why 6 for RF3?
It comes down to how RF works. RF3 means the cluster keeps 3 separate copies of your data distributed across different nodes.
Right, for resilience.
Exactly. Now, to guarantee that you can survive failures, say 2 nodes failing simultaneously or one failing while another is down for maintenance, and still have a complete, accessible copy of the data,
Yeah.
you need enough nodes to ensure those 3 copies are sufficiently spread out. The math works out that 6 is the minimum to provide that guarantee for RF3.
Okay, so it's about ensuring data availability even with multiple concurrent issues. What's the main difference then, in simple terms, between RF2 and RF3?
Well, RF2, which is the default and requires a minimum of 3 nodes, keeps 2 copies of your data. It protects you against a single node failure.
Got it.
RF3, needing 6 nodes, keeps 3 copies. So it can tolerate up to 2 simultaneous node failures without data loss. It offers higher resilience.
But uses more storage space, presumably.
Exactly. That's the trade-off. More resilience means higher storage consumption because you had that extra copy of everything.
Okay, that makes sense. Balancing protection and capacity. All right, let's move from data copies to just generally keeping an eye on the system's health.
Yeah, overall monitoring.
Question 5. In Nutanix, which component is responsible for monitoring and maintaining system health? Options: A, Pulse; B, Prism; C, Calm; D, NCC.
This one points to A, Pulse.
Pulse. Sounds like it's checking the system's vital signs. Is that the idea?
That's a good way to put it, yeah.
Yeah.
Pulse is Nutanix's cloud-based health monitoring and alerting system. It collects telemetry data from your cluster's diagnostic info, performance stats, configuration details, that kind of stuff.
And sends it where?
Sends it back to Nutanix securely. They analyze this data, sometimes using machine learning, to spot potential problems, like predicting hardware failures, identifying performance bottlenecks, maybe security vulnerabilities.
Okay, so it's not just local monitoring, it's using cloud intelligence.
Exactly. It leverages insights from the entire global fleet of Nutanix clusters to provide more proactive and predictive support. It can alert administrators or even automatically create support cases sometimes.
Why is that kind of remote proactive monitoring valuable?
It means issues can often be caught way earlier, sometimes even before they actually impact anything. Right. Admins get alerted, maybe get recommendations on how to fix things. It reduces troubleshooting time, prevents bigger outages. It's about shifting from being reactive to being proactive, using that broader data pool.
Leveraging the wisdom of the crowd, kind of? Makes sense. Okay, thinking about resources, let's talk storage efficiency.
Always a big topic, getting the most out of your drives.
Question 6. Which feature in Nutanix helps improve storage efficiency by reducing duplicated data blocks? Options: A, deduplication; B, compression; C, erasure coding; D, tiering.
The key here is reducing duplicated data blocks. That points directly to A, deduplication.
Deduplication, we hear that term a lot. How does it work in Nutanix to save space?
So basically, as data is written, Nutanix can look at the incoming blocks of data. If it sees a block that's identical to one, it has already stored somewhere else. Instead of writing that block again, it just creates a pointer, like a shortcut, to the existing identical block. It says, hey, the data for this location is actually over there.
So it avoids storing the same thing multiple times.
Exactly. It eliminates those redundant copies at the block level. This can lead to significant space savings, especially in environments where you have lots of similar data, like virtual desktops or maybe lots of copies of the same operating system files and VMs.
Right. And why is the storage efficiency piece so critical these days?
Well, data volumes are just exploding, aren't they? Storage isn't free. You need disk space, power, cooling. It all adds up.
True.
So techniques like deduplication and also compression, which often works alongside it, help you make the most of the storage capacity you already have. It pushes out the need to buy more hardware, reduces your footprint, saves costs. It's fundamental to managing modern data growth economically.
Makes perfect sense. Squeezing more value out of the hardware. All right, let's move up the stack to the virtualization layer.
Where the VMs actually run, the hypervisor.
Question 7. What is the default hypervisor integrated with Nutanix? Options: A, VMware; ESS; B, AHV; C, KVM; D, Hyper-V.
The default hypervisor that comes with Nutanix is B, AHV.
AHV, Acropolis Hypervisor. That's Nutanix's own, right?
It is, yeah. It's based on Linux KVM, but heavily customized and integrated by Nutanix.
What's the advantage of having their own tightly integrated hypervisor?
Well, several things. First, simplicity. Because it's built in, deployment and management are generally easier. It's all managed through Prism, the same interface you use for storage and everything else.
Okay, unified management.
Right. Second, performance can be optimized because they control the whole stack, from the hypervisor down to the storage. Features can be designed to work together seamlessly. And third, There are often licensing benefits. AHV is included with Nutanix, so you don't have separate hypervisor licensing costs, which can be significant with other options.
So potentially simpler, faster, and cheaper. Makes sense why they'd offer their own.
It provides a very cohesive, hyper-converged experience, yeah.
Okay, so we have this integrated system. How do we keep it all up to date? Software, firmware, all that jazz.
Ah, yes. The joys of patching and upgrading distributed systems.
Question 8. Which of the following is a primary purpose of Nutanix LCM Lifecycle Manager? Options: A, VM migration, B, firmware and software upgrades, C, data backup, D, load balancing.
LCM's primary job is B, firmware and software upgrades.
Lifecycle Manager, LCM. So it manages the life cycle of the software and firmware.
Pretty much. Keeping a complex system like Nutanix up to date can be tricky. You've got the AOS software, the hypervisor, whether it's AHV or something else, firmware for the hardware components like BIOS, BMC, drives.
Lots of moving parts.
Exactly. LCM is designed to automate and simplify that whole process. It understands the dependencies between components and can orchestrate the upgrades across the entire cluster in a non-disruptive way, usually one node at a time.
So it figures out the right order and handles the rolling upgrades.
Yes. It inventories the current versions, shows you available updates, checks compatibility, and then manages the actual upgrade process. It significantly reduces the manual effort and the risk involved in updates.
That sounds incredibly useful. Why is that centralized update management so crucial in HCI?
Consistency. Again, you need all nodes running compatible versions for stability and performance. Drift can cause problems.
Right.
And security. LCM makes it much easier to apply critical security patches quickly and reliably across the whole environment. Try to do all that manually on dozens or hundreds of nodes. That's tough and error-prone. LCM streamlines it.
Yeah, I can see the value there. Consistency and security. Okay, let's get a bit more technical now. How data actually gets written.
Down into the nitty-gritty of the right path.
Question 9. In Nutanix, what does the OpLog do? Options are A, caches frequently accessed data, B, stores backup copies of data, C, serves as a persistent write buffer, D, manages metadata.
Okay, the OpLog, its role is C. It serves as a persistent write buffer.
OpLog, operation log, a persistent write buffer. What does that mean exactly? Why have this buffer?
So when a VM writes data, getting that write acknowledged back quickly is really important for performance, but you also need to make sure the data is safe, right? That it's not lost if a node crashes immediately after the write.
Okay, speed versus safety.
Kind of. The OpLog is designed to give you both. It's a fast staging area, usually on SSDs, where incoming writes are first recorded. Critically, it's persistent, meaning the data in the OpLog survives node reboots. And it's replicated. The OpLog data is also sent to another node's OpLog before the write is acknowledged back to the VM.
Ah, so the data is safe in at least 2 places very quickly.
Exactly. That allows Nutanix to acknowledge the write super fast, giving good performance, while still guaranteeing that the data is durable even if the original node fails right away. The data is then destaged from the OpLog to the main storage tier later in the background.
So it's a performance optimization that doesn't sacrifice data integrity.
That's the core idea, yes. Fast, safe writes.
Got it. Okay, last question area. What happens when things go really wrong? Disaster recovery.
Planning for the worst-case scenario. Business continuity.
Question 10. Which tool in Nutanix helps with application-centric disaster recovery? Options are A, Flow, B, Calm, C, Pulse, D, Protection Domains.
For application-centric DR, the answer is D, protection domains.
Protection domains, okay. How do they help with recovering applications specifically?
Well, traditional DR often focuses on just replicating individual VMs or LUNs. But applications are often made up of multiple VMs, right? A database server, a web server, an app server. They need to be recovered together consistently.
Right, they depend on each other.
Exactly. Protection domains let you group those related VMs together. You define this group, the protection domain, and then you configure policies for how often snapshots are taken and where they're replicated, like to another Nutanix cluster at a DR site.
Okay.
This ensures you have crash-consistent or even application-consistent recovery points for the entire application. When you need to fail over, you activate the protection domain at the remote site, bringing up all the constituent VMs in a coordinated way.
So it's just the focus from individual machines to the whole business service.
Precisely. It's about making sure the application comes back online functionally, not just recovering scattered bits of data or individual VMs. It aligns your DR capabilities with what the business actually needs working applications.
That makes a lot of sense. Recovering the service, not just the servers. Okay. It's definitely been a good first look into Nutanix. Makes you think, what part of this complex system would you want to dive deeper into next time? Something to mull over. Until our next deep dive, keep asking those questions.